All right, so when we left, we're talking about the population represents the parameter. The sample is where we're going to find our statistic. Okay. And then when we talk about a sampling distribution, okay, we're going to actually, in this one, we're going to talk about a dot plot, okay, of the sample means. Maxwell, turn it down, baby. I can hear it. Okay. Or maybe that's Elias. No, okay. All right, so the dot plot of sample means. Okay, we'll use our applet to help us do that if we need to, which is the one quantitative variable. Single group. Okay, and then learning target 3. It's going to ask us about something being statistically significant. And to do that, we're going to look at a percentage, okay? So we're going to count our dots, divide it by the total dots, okay? And if our percent is less than 5, then it's what we call statistically significant. Okay, so that's one of the things it'll ask you. We'll count the dots in whatever range they say, greater than something, less than something. We'll divide it by the total number of dots, make it a percentage. If our number is less than 5%, then we're going to say it's statistically significant. Now, I want to show you some symbols they use for the statistic versus the parameter. Okay, so the sample versus the population. Okay, we already did mean. Okay, so for the statistic, it's X bar. For the sample, it's that crazy looking U. Okay, but that also applies to some of the other things that we've done before. One is a proportion. Remember, that's just a decimal out of the total. They use a P with a hat. Okay, they put a little roof on it. Okay, P hat. And then the population, we use P. Okay, you're not going to need that today. All right, but I just want you to know what these symbols are. And then the last one that we talk about is a standard deviation. For this sample, we use an S with an X next to it, okay? And then for the population, we use that sideways 9, okay? Or the O with the hat on it, okay? So just to show you, all right, some of the things. So they may talk or use some of those symbols today, so I just wanted you to have a reference, okay? If they say something about the sample standard deviation, you may see that S with the X. Or the population, it's that weird-looking sideways 9, okay? And I want us to just look at a couple of examples, things you could see in what you're going to do today, okay? So it's talking about it being cold during the winter. Outside temperatures at this cabin in Colorado can stay well below freezing for weeks at a time. To prevent the pipes from freezing, she sets the thermostat at 50 degrees. The manufacturer claims that the thermostat allows variation in home temperature that follows a normal distribution with a standard deviation of 3. To test this claim, she programs her thermometer by taking SRS stands for a simple random sample. So a sample of 10 readings during a 24-hour period, and the sample standard deviation is 5 degrees. Okay, so there's a lot of things there that are going to help me be able to figure this out. All right, the first thing it wants to know is what's the population and the parameter. And then we want to know the sample and the statistic. Okay, now I think the easiest way to pick these out is based on the symbols. Okay, it's based on the symbols. So when I see this sideways 9, does that go with a population or a statistic? Or a parameter or a statistic? A parameter. If I look up at the top, it's a parameter. So we would say it's 3 degrees Fahrenheit. It's my standard deviation. Okay. My statistic is the one that's the S with the X, all right? It's a little different symbol. That goes with my sample. So that one's going to be 5 degrees Fahrenheit, and that is the sample standard deviation. So I can pick that out straight from the reading. Okay, if they give me symbols, check your symbol to see which one goes with statistic or sample and which one goes with parameter. Okay, now the population might be a little bit more difficult to do. Okay, so if we look at this one, it says that the manufacturer claims that the thermostat allows variation in home temperature that follows a normal distribution. So this would be all thermostats. Okay, it goes with all of them. The standard deviation for all of them is 3 degrees. All right, it's what the manufacturer says. But when we think about our sample, are we looking at all of them? No. No, which ones are we looking at? Yeah, we're looking at just hers. And how many readings are we taking? Yeah, we're looking at just Mrs. Starnes.
Oh, 10 during the 24-hour period.
Yep, her 10 readings. Let's say her thermostat readings. Okay, so look at the symbols that are going to be in the problem. That way you'll be able to pick out, all right, the sample or the statistic and your parameter for your population. All right, that's just the easiest way to do it. Okay. Now, let's look at this one. Okay, let's look at this next one. So suppose it is working properly and that the temperature in the cabin vary according to a normal distribution with a mean of 50 and a standard deviation of 3. The dot plot shows this distribution of the sample standard deviation in 100 simulations of size 10 from this population. Okay, so it asks, would it be unusual to get a sample standard deviation of 5 degrees or greater in a sample size of 10? Okay, so let's look at our dot plot. This is that last one. We want to know, is it statistically significant? Okay, so let's look at our dot plot. How many readings are 5 or greater? 0. Okay, there's 0 that are 5 or greater. How many total readings did they give me this time? 100. And so what's 0 out of 100? 0, which would be 0%. Is that less than 5%? Yes, so the answer to this question is yes. Okay, yeah, okay. So 0 was how many were greater than 5. 100 was how many readings we took. Okay, it's less than 5%, so it's a yes. Okay, question about those two. All right, I want to look at a couple of my examples, and then we're going to be done. Okay. Okay, well, let's look at this one. We're trying to pick out the population and the parameter. We're just going to do this first one, okay, the sample and the statistic. So population, parameter, sample, and the statistic. Okay, So a Pew Research Center poll asked 743 13 to 17-year-olds in the U.S. if they have access to a smartphone. Of the respondents, 95% said yes. Okay? So let's talk. We're talking about 13 to 17-year-olds. How many did we talk to?
743.
That's my sample. 743 13 to 17-year-olds. Okay? So if that's the sample, what would the population be? It's going to be all 13 to 17-year-olds. Okay? Population, remember, is always everybody. Okay? Now, if we look at this one, it says that of the respondents, 95% said yes. So that's of the people who responded. Is that part of my everybody or the 743? 743. So my statistic is that 95% said yes. Okay. For my perimeter, it would be percent of all who say yes. Okay, and that's all it's asking you to do. Okay, figure out who's the everybody and who's the sample. All right, and then what measure they're using to do it. Okay, so there'll be a couple like that where you have to click in which one is which. All right. All right, let's look at this next one because you're going to have one like this too. I think it's a multiple choice though. Okay, so it says John and Carol have 4 grown sons. Their heights in inches are 71, 75, 72, and 68. We want to list all 6 possible random samples of size n equals 2. In other words, remember what we did on that example we started with? Let's put them together. So if I'm only taking 2 at a time, I could do 71 with 75, 71 with 72, and 71 with 68. Will I use the 71 again after that? No, because I've already used it. Okay. So then I start with the 75. Who can I put with the 75? 72 and 68. And then I'm done with the 75. So then what does that leave me still to put together? 72 and 68. So that's all your possibilities, okay, of 2 people in a group. All right. Now, the next thing it says, from this population, calculate the mean height for each sample. In other words, we want to average each sample. Okay. How would I do that? Add them up, divide by 2. Okay. So let me just give them to you. All right. We'd have 73, 71.5. These are all the sample means. 69.5, 73.5, 71.5, and 70, okay? And I trust you can put them on a dot plot, right? What would probably be the smallest number we'd need on my dot plot?
69.
Yeah, 69, 70, 71, 72, maybe up to 74. Okay, and then we'd put our dots above it. Okay, so that's all it's going to ask you to do. That's a really straightforward one. Okay. Question on that. All the possibilities. All right, let's skip example 3. Okay, we're going to skip that one. And let's look at this one. Okay, there's a lot of information on here, but I just want to be sure we understand about getting those percentages to know, is it statistically significant? Okay. So to determine if a sample proportion of p-hat 0.63 provides convincing evidence that Mrs. Chauvet cheated, the class simulated 100 simple random samples of size n equals 30, assuming that she was telling the truth. That is, they sampled from a population with 50% black beads. For each sample, they recorded the sample proportion of black beads, and the dot plot shows the results. Okay, so in other words, each dot represents the percentage out of 100 pools. Okay, there's 100 of them. So there is one dot on the graph at 0.7. What does it represent? Okay, so that just means in one sample, If it's 0.77, what percent would that be? 77% of the beads were black. Okay, so that's just how to read it. All right. Then on part B, said, would it be unusual to get a sample proportion of 0.63 or greater in a sample of size 30 when P equals 0.5? And let's explain our reasoning, okay? So here's what we want to do. We just got to figure out on this picture, where's 0.63 or more, okay? So I'm going to go with 0.63 are these dots right here, greater than 0.63, okay? If I count them, how many dots is that? I think it's about 9.
Yeah.
Yeah. So about 9. And how many dots did they tell me I had up there? 100. Okay. So that would be 0.09, which would be what percent? 9%. Okay. Is that the number we want? No, we want it to be less than 5. So my answer to this question is no. Okay. And then on part C, it says, based on the actual sample in your answer to part B, is there convincing evidence that she lied about the box? Okay. And then we're going to say no, because 9% is not statistically significant. Okay. Doesn't meet that 5% requirement. Okay. All right, so those are the kind of things it's going to ask you today, right? So you're going to need a calculator, all right? You might, if you have a lot of data, you might want an applet to do your dot plot, but you probably won't have to be a very big data sets, I don't believe. Okay? All right, got 5 questions on your assignment. Let's get it. Okay, should be lesson 7.1. And there's some laptops up here.